An aircraft has a liftoff speed of 120 kilometers per hour, so that's going to be a velocity. So one of our givens is going to be velocity. What acceleration does this require? So we're going to be looking for acceleration. So we have our given, we have 120 kilometers per hour is an velocity. We're looking for what acceleration? So our unknown is A. Does this require if the aircraft is to be airborne after a takeoff run of 240 meters? So meters, okay, that's going to be an X. X equals 240 meters. I wrote down some of the givens, the unknown, but we also need to draw a picture. So if anyone's ever been on an airplane, that's pretty good. Okay, so here's my airplane, and they have wheels at the beginning. Okay, and it's on a runway. In order for it to be airborne at 240 meters, so let's say this is 240 meters, it has to be right here at a velocity of 120 kilometers per hour. So that velocity looks like it would be actually the final velocity. Okay, so we get that based off of the picture. Because planes, when people get on, the velocity initial is actually 0. Okay, so it's going to actually be looking for VI equals 0. VF is that. So what that means is we actually can add in another given. So VI is 0 meters per second. Notice, kilometers per hour, meters per second, meters, we need to convert this kilometers per hour. So over here on the right, I'm going to convert, we start with 120 kilometers per hour. Kilometers are on top, so kilometers must go on bottom to cancel out. Okay, we're trying to convert kilometers to meters, and kilometers bigger, so it gets to 1. There's 1,000 meters in a kilometer. Okay, so kilometers are canceled. We now have meters per hour. We want meters per second, because usually in acceleration we want seconds anyway. Hours we want to get rid of, so if they're on bottom, we have to put hours on top. We're trying to convert hours to seconds, so in order to convert hours to seconds, we're going to have to put seconds on bottom. Hours is going to cancel out. Since an hour is bigger, it gets to 1, and there's 3,600 seconds for every hour, so hours cancel out. We can just multiply across 120 times 1,000 divided by 3,600, and that is going to give us, in meters per second, our velocity final. So someone took my calculator last semester, so you can blame them for you having to wait for me to grab my phone. So 120 times 1,000 divided by 3,600 is 33.3. I almost guessed that. Okay, so 33.3 meters per second is our velocity final. So instead of this, we actually now have 33.3 meters per second is our VF. Now we can move on, equation. So we need A, X, VI, VF. So X, this one does not have X. This one has X. This one has X, has X, has X. VI, this one does not have VI. This one has VI, this one has VI, this one has VI. VF, this one has VF, this one does not. This one has VF. Now for acceleration, notice this one does not have acceleration, can't use it. Only left with 1, which is usually a good thing. So I'm going to use that bad boy. VF squared equals VI squared plus 2AX. Ooh, I got text. So, sorting. Solving for A. So we're going to do PEMDAS backwards. Notice, these are being added to each other. So first thing we're going to do is subtract. VI squared. Woo. These are kind of close. So, for sorting, we're going to have VF squared minus VI squared equals 2AX. No more addition subtraction. Move on to multiplication division. We can now divide by 2x. Notice how that's going to cancel out on the right, and it's going to leave us with just a. So we're going to have VF squared minus VI squared divided by 2x equals a. From here, substitution. All we're going to do is plug these in. So VF, we said, was 33.3 meters per second. I'm going to square that bad boy. 0 meters per second. I can do this one without my calculator. That's 0. 0 squared. And then we're going to divide it by 2. And then also divide by x. And this is going to give us our acceleration. So do that in your calculator, and you should get your acceleration. Make sure, even though this is 0, you need to make sure you do this VF squared minus VI squared before you divide. You have to do the top before you divide. The reason why is because this denominator goes all the way across. Also, when you divide, I would first divide by 2 and then take that divided by 240. To me, it's just easier because calculators are sometimes wonky and they will do weird things, and it's just ugh. So we are left with 2.31 meters per second